Let's talk about FEN strings. So FEN strings are an easy way to represent a chess position in a chess game. Right now, we take the chessboard, we store it in an array of size 64 because that's how many square a chessboard has. Each square is represented by the index in the array starting from 0 all the way up to 63. Each piece in the chessboard has its own index, which we have represented so far, and the index in the array corresponds to which piece is at which position. That is the way we do things now. And although it is a fairly good way to do it, a more easy and more efficient way is to use FEN strings. How do they work? This is the starting FEN string. The first few letters represent the different pieces on the first rank. The small case letters indicate the black pieces and the capital letters indicate the white pieces. So R is for the rook, N for the knight, and so on. Slash is represented by the next rank, and the numbers which you can see, for example, in this case 8, is how many squares we have to leave before the next rank. Unity project where we last left off. Right now, we have a functional chessboard where the pieces can move, but there are no legality in the moves. The pieces can move anywhere they want. There are no checks. You can capture the king directly, and there is no win or lose condition. In this case, as we talked about, we are going to create a FEN string functionality. So let's go ahead and create new C# script. I'm going to call it FEN string utility, and let's go ahead and VS Code to create the script. This script doesn't need mono behavior, so we are going to get rid of that. And same thing with the Unity engine and systems.collection lines, we can get rid of those too. This is going to be a standalone class because it is a utility class, so we can also get rid of the boilerplate code, the start and update functions. Okay, so the first thing we're going to need is a dictionary which can translate from the characters in a FEN string to the indices we have defined in our piece utility class. So K is going to be the king, Q the queen, and so on. Next, we need a class to store all the information a FEN string provides, which is the position of the pieces, castling rights for black and white, en passant file if there are any, and the ply count, and whose turn it is to move. The first function we're going to create is the FEN string to position function. Inside this function, first we create a new variable using the position info class we have defined. Then we split the FEN string into sections using the split function, and I have given the space as the character for which is the basis to split. Then we iterate through the first part of the FEN string to get the actual position onto our chessboard class. So for that, we initialize the file and rank variables to 0 and 7 and iterate through. So first we check if the symbol is a slash. If it is, then we set the file variable to 0 and the rank variable we decrement it, because we are moving on to the next rank, and the next rank will always start with the leftmost file position, which is the A file. If the symbol in the FEN string is a digit, we increment the file by the digit. That is because it is the number of spaces which we have to leave. If it is neither of these cases, then it is a piece. Then we check if the color is an uppercase or lowercase to check if it is the black piece or the white piece. And we do that by using the piece, the character class is upper function, and we have already defined the indices for the white and black variables in the piece utility class. Next, we check the piece type. We already have a dictionary for that. Then we store the piece information in the position information class using a piece type and the bitwise operator piece color to store the entire piece value, and we increment the file by 1 for the next iteration. This is the entire iteration for checking each piece. We have provided all the checks. After that, to check which it is to move, we directly go to the next index in the sections variable and check if the letter is W. If it is, then it's white to move or it is black to move. Next, we check the castling rights. The way we do this is not all FEN strings contain castling rights. If the length of the sections variable is greater than 2, then castling rights are included in the FEN string. Otherwise, all castling rights are still available. For this, we just check if the castling rights variable or the string which we have declared contains the KQ for both the small case and the uppercase variables, letters rather. And if it does, then we set the section's length is greater than 3. That means the en passant file is there. And to check the en passant file, first I'm going to create a new string called file names, which is going to contain all the file names from A to H. And then I'm just going to create a small check. The file names variable has the en passant file name, and if it does, then the en passant file is set to the index of the file name plus 1, because it starts from 0 and the actual file starts from 1. Okay, so the next thing we're going to do is the ply count, which we can easily do by try parse. This is the entire function for getting the position from the FEN string. Now we need a function to get the FEN string from the already desired position. So first of all, we are going to initialize the FEN string to a null string. After that, we are going to iterate through each of the files and ranks, rather the chessboard, one by one. Each iteration of the rank or each iteration of all the 7 or 8 files, we are going to set empty files is equal to 0, which we'll see why we do that later on. Then we get the index of each square using this formula, which you can see. Then we get the piece on the chessboard using this index. Then if the piece is not equal to 0, meaning that if there is a piece on this square, then we check if there are any empty files beforehand. If there are, then we add the number of empty files to the FEN string, and we again set the empty files variable to 0. We check if the piece is black using the function which we have already declared in the piece utility class. After that, we get the piece type again using the piece utility class, and now we need to check which piece it is. Rather, we need to get the character of each piece. So the way we do that is we are going to use a switch case style. So we check the piece type to each of the variables, and accordingly we set the character for the piece char variable. And after all of that is done, okay, so there are some errors, and that is because the switch case function expects the case to be constants, but we have them declared as statics. So I'm just going to change all of these to constants. We have the piece character, we are just going to add it to the FEN string. And the way we do that is, if it is black, then we set it to 2 lower, and if it is white, then there's no need to set it to the lowercase. Then we increment the empty files if there is no piece, and at the end, if empty files is not equal to 0, we add these number of empty files to the actual FEN string. Any rank other than the first rank, in which case we will add a slash, a space, and then set which turn it is, that is white to move or black to move. After that, we can add the castling rights, but we haven't implemented the functionality for both the castling rights and for the ply count, so we're going to leave that for now, and then we just return the FEN string. So this is the entire position to FEN string. Now we move on to the chessboard, where we have to actually implement the function to load all the information from the FEN string to the chessboard. So we are going to create a brand new function called load position, which is going to take in as parameter the FEN string, whichever FEN string we supply to it. And we want the initialization to be done inside this function, because we are going to call this function from the game manager. We are going to remove the constructor function for this class. We're going to call it init, and then we're going to call this init function from inside the load position function. Okay, so we call the init function, then we get the position info from the FEN to position function which we have just declared. Then we iterate through the entire chessboard. We get the piece, we get the information of the piece, and then we store the piece inside the position variable. Here I'm just going to create a new variable for no piece, which is usually a good practice. After that, we get the piece type, we get the piece color, and then we set it to the white index or the black index. We do that by using the check color function, which we have already implemented, and comparing it to the white index. After that, what we're going to do is use the if else statements to compare which piece is present on the board, and then accordingly we are going to store all these information in the piece lists we have declared before. So for example, the king squares, the queen squares and all that, we are going to do this for each piece type. Then we are going to check which turn it is to move, which color it is to move, and if what is the opponent's color and what is the color to move index. After that, we are going to make a few modifications in the game manager. Okay, so a new thing what I want to do is, instead of checking the board UI by find object of type, which is a very slow function, I'm just going to serialize field this board UI variable, which will make it open in the inspector function. Next, what I'm going to do is convert the FEN string which we had declared in the last video to a constant, and then I'm going to set this constant as the default value of the FEN string parameter which we pass in the load position function. Then I'm going to call this load position function inside the game manager, and then now we're going to modify the generate board and spawn pieces function. So we're going to get rid of the old spawn pieces function and rewrite it completely. The way we do that is we iterate through the entire board one by one. Then we get the piece information by, here I'm just creating a helper class to get the square index from the file and ranks. Then what we're going to do is get the piece information from the board which we are passing as a parameter for the spawn pieces function. After that, we set the sprites array using the spawn piece function which we had declared all the way back in the first or second video. We get the piece type and piece color using the piece utility classes. We need to position the pieces and resize the pieces accordingly. So we're going to move that piece of code from the generate board function to the spawn pieces function. Then we call this a spawn pieces function directly from the game manager itself. Now we can go back to Unity, check if everything is working fine, and I'm going, okay, so there is an error. Okay, so I have fixed the error. There were two small errors which I have fixed. First is in the chessboard class. Earlier what we were doing is, we were inside this for loop, we were iterating from index is equal to 0 all the way up to board UI.square count, which is just 8 squares. What we actually need is the total of 64 squares. So we need to multiply square count into square count, which gives 64 squares. Now if we run everything works fine. So that's going to be it for this video, guys. I'll see you in the next one.